Hey folks, let's take a look at a particular form of quadratic relation, and that is the vertex form. Now, this is my personal favorite. I know I shouldn't probably pick favorites, but it's my personal favorite because when I look at it, it tells me a lot of information, and I don't have to pick it apart that much to get even more information out of it. So we're going to take a look at what each of these things does. What does A do? What does H do? And what does K do? Each one of those variables does something different to the equation, and also when it's graphed, it does something different to the parabola. When we change a number in an equation like this, and the graph changes, we're going to call that a transformation. So um, the parabola will transform into something different than it looked like before. You can see here we've got a graph of y equals x squared. Okay, so that's kind of our standard basic parabola, y equals x squared. Everything else, we're going to look at it as kind of a version of that. So let's take a look at each one of these letters. First of all, what does A do? And A actually has the same function in all forms of quadratic relations. You're going to see A is in standard form. We've already seen that. And A is also in factored form. And in all three cases, A has the same function. What A does is it vertically stretches or compresses it. Okay, so you can write this down and then I'll show you what it looks like. So if A is greater than 1, if it's a bigger number than 1, or if it's less than -1, so its absolute value is greater than 1, then what's going to happen is the parabola is vertically stretched. So if you imagine the two kind of sides of a parabola pointing upwards to the sky, this is sort of like they're pointing straight up now. They're being vertically stretched. I'll show you an example of that. So here we have y equals a x minus h squared plus k. That's a vertex form. So what I'm going to do is I'm going to grab this slider and I'm going to increase the value of a. So you can see now a is 3. And the red parabola there, you can see the higher A goes, the more vertically stretched it gets compared to the original y equals x squared. So the higher A is, the more stretched it gets. Now, also, reverse, the lower it gets below -1, the more vertically stretched it gets, but just in the opposite direction. Okay, so that's vertical stretch. If A is between -1 and 1, so it's like a 0.5 or -0.7, then the parabola is going to be vertically compressed. So the parabola is vertically compressed. And I like to imagine this as sort of like, at least for the positive numbers, the arms of the parabola are pointing upwards, and as the weight increases on it, it's being compressed, and you can see as it hits 1, it gets below 1, it appears wider and wider, so it's being vertically compressed. So I can go, let's say I can go down to a really low number like 0.05, and it's quite compressed. And the same thing with negative. If it's right, the closer we get to 0, the more compressed it is. And if you think about what's happening there, if A is close to 0, what it's going to do is it's going to make all the numbers it's being multiplied by smaller, right? And so the y values are going to grow very slowly. I like to think of A as like fertilizer. And so the bigger the number, the quicker the y values grow. And so if it's a very small number like zero point 0.3 or negative zero point 0.3, that's like putting negative fertilizer on because you're multiplying it by less than itself. So that's what A does. It vertically stretches or compresses it. As well, you may have noticed that the whether A is positive or negative makes a difference as well. If A is greater than 0, in other words, if it's positive, then the parabola opens upward. And I like to think of that as if it's positive, then it's smiling. right? So if it's a positive a, then it looks like the parabola is smiling. And if the a is negative, it's less than 0, then the parabola opens downwards. And again, using the same analogy, if it's a negative a, then it's frowning because it's so negative, right? And so, and again, we'll just go back to this. You can see if a is anywhere below 0, it's opening downwards. If anywhere above 0, it's opening upwards. So a has two functions: vertical stretch and compression, and also the direction of opening for the parabola. So that's a. And that's the same thing that a does for all three forms, as I mentioned earlier. Let's take a look at h. H is kind of a tricky one. So I'll tell you on the note here, if h is greater than 0, so if it's a positive number, then the entire parabola is shifted to the right. That's probably what you would expect, right? A positive number is going to shift it to the right. But here's what's confusing about that. In the formula, it's a times x minus h. So let's say it was y equals 2x minus 8 squared plus 2. And I said, what's h? You might want to say that it's negative 8, but it's actually not. So the formula is x minus h. So you're subtracting whatever h is. So what is h then? H is actually a positive 8. So that one's kind of confusing. That often gets people. So when h, the number h, not according to the symbol in front of it, but when h is positive, then the parabola is shifted to the right. And if h is negative, as you can probably guess, the parabola is shifted to the left. So how do I know if h is negative? And again, this can be confusing. So let's say, I'll just change colors here. Let's say this was x plus 8. Okay. If it's x plus 8, the formula is x minus h. So what's actually happening here is it's x minus negative 8. If this is confusing, I would just say always just switch the sign in front of the h and you'll have the right answer. Okay, so h causes the parabola to shift from to the left and to the right. So let's take a look at it here. So I got my h slider here. As I move it positive, you can see the entire parabola moves to the right. As I move it towards the negative, it moves to the left. So if it's less than 0, it's going to be to the left of the y. The vertex of this parabola is going to be to the left of the y-axis. If it's greater than 0, the vertex is going to be to the right of the y-axis. So that's what h does. K is very similar, except k translates or shifts the parabola up and down. So if k is greater than 0, if it's a positive number, then the parabola is, shifted with a t. Parabola is shifted upward, k units. And if it's negative, then the parabola is translated or shifted downward. Okay, so I'll go back, we'll take a look. So as you can see, if k is bigger than 1, it's translated upward, or bigger than 0, I should say. If it's less than 0, it's translated downward below the x-axis. Okay. So that's what A, H, and K each do. So we're going to take a look at this in a graph, and then you guys can have some fun graphing this. I really encourage you to try out desmos.com and do some of this yourself. You can actually go to desmos.com, and they have this Vertex form thing sort of preloaded. So if you just go to desmos.com and you click on the top left here, they've got a bunch of preloaded examples, and Parabola's Vertex form is actually one of them. So super handy way for you to practice Vertex form and see what each of those letters actually does. So let's just finish up this part of the note. The coordinates of the vertex, and I don't know if you noticed this, the coordinates of the vertex are actually just h, comma, k. Right? So let's go back. If I shift, let's see, I go h 3 and K2. It's been shifted to the right and up, and the vertex itself is actually 3, 2. So whatever h and k are in the equation, in the relation, will actually be the vertex. This is one of the things I love about vertex form, is it gives me that piece of information right away. The axis of symmetry will be, that's that vertical line that splits the parabola into two symmetrical halves. The axis of symmetry will just be x equals h, whatever h happens to be, right? So if the formula for it was, let's say, use the same one as before, h here is going to be positive 8, right? So the formula for the axis of symmetry would be x equals 8, right? And that's a vertical line that passes through 8 on the x-axis. And then the maximum or the minimum, in other words, the highest height that the parabola reaches, or if it opens upward, the lowest point it reaches is going to be y equals k, right? So again, using the same example here, this is k, so 3. 3 is going to be, well, let's see, it's positive 2, so it opens upwards, so it's going to have a minimum, right? So the lowest point on this parabola will be 3. The minimum will be 3. Let's take a look at some examples and see how this works. Okay, so here's an example. Here's the equation. Now, right off the bat, you might be saying, hey, what happened to the h and the a? I don't see them. So if a is 1, then it kind of disappears. You don't need to say multiplies by 1. That's sort of redundant. And if h is 0, well, x minus 0 is just x, right? So when you see this form, it doesn't look like it, but it actually is vertex form. The h will be 0 and the a will be 1. And we see this is written out here. So that means that it won't be vertically stretched or compressed. It hasn't been translated to the left or the right, but it has been translated upward by 4 units. So let's take a look at what that would look like on our Desmos graph. So let's see, y equals x squared plus 4. Here we go. So it has been shifted upward, but it hasn't really been stretched or compressed. Let's do a few more. So let's say we've got a parabola that has been stretched vertically by a factor of 2. So that's going to be a, right? And shifted 3 units to the right. So that means that h is 3. It doesn't say anything about it being translated or shifted upward or downward, so that means k must be 0. So what would that equation look like? Well, let's write out the form. So y equals a times x minus h, that's 3, squared, plus k, except k is 0, so we don't have to write it. Okay, let's take a look at another one. Shifted 2 units to the left. Pause the video right now and give this a try yourself. Okay, hopefully what you've seen is that it hasn't been stretched or compressed, so a will still be 1. It's been shifted 2 units to the left, so that's negative 2, and it hasn't been translated or shifted up or down at all. So it should be like this. I could put a 1 in front, but that's a bit redundant, so I won't bother. So I'll just say x minus h, but it's a negative 2. So x minus negative 2 is plus, and then again, plus 0. I don't have to write that. Okay, here's another one. Compressed vertically by a factor of a half. So again, when we're talking about vertical compression or stretch, that's a. Right, so we've got a half, and it has a vertex of negative 5, 2. Well, we already know that the vertex is h comma k, right? So that means that we're going to have an h value of negative 5 and a k value of 2. So let's plug that into the formula. So it's y equals a times x minus h. Subtract negative 5 is a plus 5 squared plus k, which is a 2. All right, let's do one more thing. Now this is kind of tricky. So this parabola has been reflected in the x-axis. What that means is that it has basically, there's a mirror image of it on the other side of the Cartesian plane. So if it was right side up, it's upside down now. Okay, so what that means is that if we're looking at all of these being a transformation of y equals x squared, what would happen if I took y equals x squared and I just flipped it upside down? Let's see what that would look like. Okay, so y equals x squared looks like that. What would I need to do to flip that upside down? Like, and not to do anything else to it. I could just make it a -1, right? And that would flip it right away. Right? So I have an a of -1. If I make a negative, I flip it upside down. And it's been translated 6 units to the left, which means that my h is -6, and 2 units up. So that's a 2. So let's write this out. Y equals a. It's -1, but I actually don't need to put the 1. I can just put a negative. X minus h, so x minus -6 is x plus 6 squared, plus k, which is a 2. Okay, so those are all vertex form, although, as you can tell, sometimes vertex form, the k is invisible, sometimes the h is invisible, and quite often the a will be invisible because it's a 1. So that's just something to be looking out for. A few more things for you to try at the bottom of this sheet. So why don't you go ahead and pause the video and see whether you can fill this out. So take a look at that formula, and then just based on the formula, without even graphing it, can you come up with what's the vertex, where's the axis of symmetry, and what's the y-intercept, and so on. So pause the video right there. Okay, so hopefully you didn't have too much trouble with that. So let's take a look at it. Coordinates of the vertex are h comma k. So that's going to be 3, 5. The equation of the axis of symmetry, we know that is x equals h. So that will be x equals 3, vertical line running through 3 on the x axis. Now, what's the y-intercept? Okay, now the y-intercept doesn't show up for us in this form, right? None of those numbers directly tells us the y-intercept, but we can actually find it out pretty quickly by just subbing 0 in for x. So let's do that. Okay, so -3 squared is 9. And -9 plus 5 is -4. Okay, so the y-intercept is -4. What direction does it open? Well, it's got a little negative out front there, so it's sad, right? So direction of opening is downwards. What values may x take? So what could x be in this parabola? Well, if we actually look on any parabola, this parabola is going to go on forever in both directions. So x could actually be anything. So the way that we're going to write that x could be anything is this. X could be any real number. That's what that r stands for. What values might y take? Okay, so what are some limitations of this? So if I'm going to graph this out, are there some values that there could never be for y? I'm going to graph it for you to see what it looks like. Let's see, we have negative x minus 3 squared plus 5. Okay, so we can see that that the parabola goes down forever, and so any negative value would be possible for y, but then it hits a maximum here of 5 at the vertex, right? So because it opens downwards, it has a maximum, and therefore its maximum value is 5. So another way of saying this is that y could be any real number such that y is less than or equal to 5. So y could be any number you can imagine, any real number, as long as it's less than or equal to 5. And I don't actually have to graph that to see it. I can just pull that y value out of the vertex, and that will tell me the maximum or the minimum. Let's do one more real quick, and that'll be it for today. Okay, so coordinates of this vertex is going to be hk. We know that since this is a positive, then we're going to switch that to -4, -7. Axis of symmetry will just be the h value, -4. Y-intercept, we just plug in 0 for x. And you can hear my phone ringing in the background. That's kind of fun. Okay, so 4 squared is 16. A half times 16 is 8. 8 minus 7 is 1. So the y-intercept is simply 1. What direction does it open? Well, it's a positive number. A is positive, so it's smiling, it's happy. It opens upward. X, as with any parabola, could be any number because it goes on forever in both directions, negative and positive. Y could be any number except there's going to be limitations. Now, if it opens upwards, that means that its vertex is going to be at the bottom of it, right? So this parabola is going to have a minimum, and that minimum is going to be the y value of the vertex. So y can be any real number such that y is greater than or equal to -7. And that's it for today. Take a look at the homework on the lesson post, and I hope it goes well. Let me know if it doesn't.